Okay, in this problem, you're dealing with the standard normal curve. And the standard normal curve has a mean of 0 and a standard deviation of 1. So standard normal curve, remember all the numbers have been standardized into z-scores. So it has a mean of 0 and a standard deviation of 1. Okay, so it has a mean of 0 and a standard deviation of 1. Okay, now the first question here says what percent of the standard normal is found in each region? And I already did the first question before I started recording, but we want to know the z values that are greater than 1.4. So remember the standard normal curve has a mean of 0 and a standard deviation of 1. So 0 is going to be right in the center of the curve. So 1.4 is going to be to the right. But if you want the values greater than 1.4, it makes sense that this would be the area. So that is the correct graph. Now, you want to find the percent of the area to the right of z equals 1.4. Now, you're going to use the norm dist function on your calculator. On the computer. There is a norm s dist function on the computer that only deals with the standard curve, but just to be so that we're always just doing the same thing, I'm just going to use the norm.dist function, but you could use the norm.sdist function if you wanted, because you're dealing with a standard normal. Now, when you want the area to the right, you have to use 1 minus the function. So when you want the area to the right, you're going to use the command is going to be equals, and then if you want it as a, if you want the percent area to the right, you're going to do the equal sign, and then you're going to do parenthesis 1 minus, and then you'll do norm dot dist, and then parenthesis, and then you do the x value, the mean, the standard deviation, and then 1. Okay, and then close that parenthesis again, so 2 close parentheses, and then if you multiply it by 100, it'll make it a percent. So that's the command if you want to do it all in one line, be real snazzy. So for the area to the right, you have to do the 1 minus the norm dist. So on this problem, we're going to go equals, and then we'll type norm, and as we start typing it, we can see norm dist, and then we're going to do 1.4. I forgot to do the 1 minus, I'm sorry. Okay, so we're going to do the equal sign, we do parenthesis, and then 1 minus, and then norm.dist 1.4, comma the mean, which is 0 here, comma the standard deviation, which is 1, and then you always just say comma 1. And then close that. Now close the parenthesis so that you can multiply by 100, and it'll give you the answer right as a percent. So this is 8.075. Now, they want it rounded to 2 decimal places, so you can get this to round to 2 decimal places for you by just decreasing the decimal, pushing this button so it decreases. So that's 8.08. Okay, let's continue to the next question. It says, choose the correct graph for z equals 1.45, but less than 1.45. So here we are looking at the 1.45, and then the less than means the area to the left. So it's clearly D again. Now, if you want the area to the left, I'm going to copy this command or these notes. But let's say, what are we going to say? If we want it, change it now, and we want it to the left, well, we don't have to use the 1 minus function, so we can take that out. Now, we can still do the times 100, but we don't need these parentheses. It won't hurt to have them, but you don't have to have them. So you're just going to do norm dist, and then x, mean, standard deviation 1, and then times 100 if you want the area to the left. So on this problem, the percent of the area to the left of z equals 1.45. All you have to do is say equals, and then the norm dist function, excuse me, and then 1.45 is the x value, comma the mean, which is 0, comma the standard deviation, which is 1. You always say comma 1. And then let's multiply that by 100 to make it a percent. And then you can use your little button if you want to round it. Get on the cell, and then you can get it to round for you. 92.65. Okay. To use the correct graph, okay, when you have to find the numbers, let's see, in between negative 1.64 and 2.45, hopefully it's hard to tell the difference between C and D, so let me just look. It's either C or D. Oh, but C has this part shaded in, so that's not right. I had to maximize it to see that, though. So it's going to be D again, which is kind of strange, but anyway, it's D again. Okay. Now, if you want the area between, the percent area between, then you have to do the equal sign, and then we'll do a parenthesis because we're going to multiply by 100. And this one is, you're going to subtract the norm dist with the larger value. You're going to subtract the smaller value from the larger value. So you have to do norm dot dist, and then x, large X, the larger X, comma the mean, comma the standard deviation, comma 1. And then what you'll do is you'll subtract, so minus that same command, norm.dist, but you'll do the smaller x, comma the mean, comma the standard deviation, and then comma 1. And then, okay, close that parenthesis, and then close parenthesis on the whole thing and do times 100 to make it a percent. Okay? So for this problem, we'll do equals, and it'll be norm dist, and we're going to do the larger x, which is 2.45, comma the mean, comma the standard deviation, comma 1, minus another norm dist, and then negative 1.6, comma the mean, comma the standard deviation, comma 1, close parenthesis. Oh, and I forgot to put the big parentheses around this whole thing, so I'll come in here and I'll do a parenthesis here, and then here, and then times 100 to make it a percent. So 93.81 rounded to 2 decimal places. Okay, continuing. I want to look at the graph of the absolute value of z is greater than 1.25. Well, what this means is all the area, either z is greater than 1.25 or z is less than negative 1.25. You may remember that from your college algebra class or something like that. But a greater than in absolute value has all the numbers to the right and then all the numbers to the left of the opposite of that. So that's choice B. And now, if we want the percent of the area, we want it to the right. Actually, this area is, these areas, we have symmetry here with the standard normal curve, so you actually just can double one of these areas. So the easy one to use is to find the negative 1.25. That's just going to be the norm dist, and we'll just multiply that by 2. So we'll say equals, and then we'll do 2 times the norm dist function of the negative 1.25, comma the mean, which is 0, comma the standard deviation, which is 1, comma 1, and then we're going to multiply that by 100 to make it a percent. And the reason we doubled it is because it's the same, the area to the right of 1.25 is the same. So 21.13 rounded to 2 decimal places. Okay, so that should help you with that one.